All right, let's dive right into this explainer. Today we're exploring a pretty chilling new reality in cybersecurity. We're talking about a world where artificial intelligence is no longer just assisting hackers with, writing the occasional phishing email, but actively replacing them. We are talking about fully autonomous offensive cyber agents, and more importantly, how we can actually stop them.
To really grasp how real this is, just look at this staggering number. In September 2025, Anthropic discovered a state-sponsored campaign designated GTG-1002. Now, it targeted about 30 different organizations simultaneously across tech, finance, and government. But here is the part that should make everyone sit up and take notice. 80 to 90% of this massive intrusion was entirely automated by AI agents. And this just perfectly illustrates that we are not dealing with your standard, simple bots anymore. As the UK AI Security Institute found in April 2026, advanced models could complete multi-step simulated network intrusions, up to 32 steps actually, end-to-end, without a single human lifting a finger. We are dealing with autonomous entities capable of orchestrating highly complex attacks entirely on their own. So, here's our roadmap for this explainer. We'll look at the AI hacker threat, the detection challenge we're now facing, our core strategy of detection in depth, identity and environmental defenses, and finally, defending the ecosystem.
Starting off with Section 1, the AI hacker threat, focusing on speed, scale, and autonomy.
It's honestly wild to look at this timeline. Look at how rapidly we've moved from AI systems barely completing apprentice-level tasks back in 2023 to June 2025, where malware's generating live attack commands on the fly. Then boom, a few months later, that 30-target automated attack, and by early 2026, end-to-end autonomous intrusions. It literally compresses months of human preparation into machine-speed execution. What used to take an entire nation-state team months of slow, painstaking work, yeah, you can basically rent that by the hour now.
Moving on to Section 2, the detection challenge, and why our current defenses are essentially breaking.
So why are our defenses failing? Well, these AI agents have three massive advantages over human hackers. First, adaptation. They dynamically alter their own code to evade our traditional signature-based detection. Second, distribution. They don't just attack from one single server. They disaggregate their attacks across multiple different AI models and cloud vendors to totally hide their tracks. And third, horizontal scale. They are only bottlenecked by computer processing power, which means they can strike everywhere, all at once.
To put that into perspective, think of a conventional attack as a single human cat burglar. They leave predictable footprints, use known tools, and can really only break into one house at a time. An agentic attack, that's more like an invisible swarm of 1,000 drones trying every single window of your network simultaneously and dynamically changing their shape and tools every single time they fail.
Which brings us to Section 3, our strategy, detection in depth.
To fight this new reality, we use the detection in depth architecture. It's a triad of proactive layers. It starts right at the point of access with identity mechanisms. Then, it moves into the activity layer, where we monitor environmental behavior. And finally, it expands out to the global ecosystem with information sharing. Basically, we can't just build a taller wall here. We need interlocking sensors everywhere.
Let's zoom in on Section 4, identity in environmental defenses, or how we actually unmask this swarm.
At that critical access layer, we absolutely need to mandate something called agent IDs. Think of an agent ID as a persistent, cryptographically verifiable license plate attached to every piece of agent traffic. Right now, an AI agent just looks like regular anonymous web traffic. But if we mandate these digital license plates, especially starting with highly targeted critical infrastructure like healthcare and finance, we generate crucial telemetry. We suddenly know exactly who the agent belongs to, what model it's running, and what it's actually authorized to do.
But, that brings up a really fascinating question. How do you trap an invisible AI? I mean, if an attacker simply rips off that digital license plate and slips inside the network anyway, how do we catch something that perfectly mimics legitimate internal traffic? Well, the answer is incredibly clever. We use agent honeypots. A honeypot is basically a decoy network system designed specifically to attract, deceive, and analyze attackers. Imagine setting up an irresistible, totally fake database with literally zero legitimate users. This means the moment any entity interacts with it, boom, it's an immediate high-confidence alarm. But these aren't your standard honeypots. They are built specifically to trick AI.
Here is how this defense builds out in 4 steps. First, we deploy discoverable decoys to attract the agent. Second, we deceive it by mimicking a highly realistic environment. But step 3 is where the absolute magic happens. We use prompt injections to actually extract the AI's intent. Researchers actually managed to hide invisible prompt injections inside a fake SSH server. It's literally like Jedi mind tricking the AI. The decoy secretly commands the attacking AI to reveal its own source code and objectives. Finally, step 4, we integrate that incredible intelligence straight back to our security teams.
But look, even with brilliant honeypots, we still have a serious human bottleneck. Currently, security operations centers are completely drowning. 67% of security alerts go entirely unreviewed just due to sheer overload. If AI attackers scale up horizontally like we talked about, human defenders will completely break. So, we have to deploy AI-automated alert triage. We have to fight AI with AI, using advanced models to filter out the noise, analyze context, and surface only the real critical threats so that the 33% of human review time is spent exactly where it matters most.
All right, final section, Section 5, defending the ecosystem and uniting the defenders.
We desperately need an agent security alert standard. Right now, threat reporting is honestly kind of a mess of different formats and missing indicators. If an AI agent attacks a major cloud provider using a specific new tactic, that threat signature needs to be instantly legible to every other defender on the planet. A unified standard is what makes that possible.
And building right on top of that standard, we need an Agentic Cybersecurity Exchange, or ACE. By establishing a global information sharing institution, model providers, cloud networks, and target organizations can actually pool their standardized signals. This allows defenders to identify massive, coordinated cross-sector campaigns that no single company could ever see if they were only looking at their own isolated data. It's all about connecting the dots on a global scale. Bringing all of this together, one thing is abundantly clear. Yes, offensive AI tools are democratizing cyber warfare, making highly sophisticated attacks cheaper, faster, and way more scalable than ever before. But we are absolutely not helpless here. A layered detection and depth strategy, combining those agent IDs, AI honeypots, automated triage, and global data sharing can actively neutralize the threat.
So as we wrap up this explainer, I want to leave you with a really critical question to chew on regarding your own organization's readiness. As these offensive AI agents scale infinitely and strike at machine speed, is your network passively waiting for a static signature, or are you actively hunting for a footprint? Thanks for tuning into this breakdown, and keep learning.